Now, this isn't a big leap from what we've been doing. It's just adding a little more complexity, adding a little bit of an extra step, and then we carry on as usual. Okay? So, what can I do here? I picked an example where it's reasonably straightforward. We've been saying if you can get the numerator in terms of the denominator, that'll be good because then you can get things to cancel out. Okay? Now, is there anyone who can see, like right off the bat, what might be the most straightforward way to get the numerator? They both have the same degree, right? How could we get this very easily in terms of the denominator? Any suggestions? Remember, my goal is just to cancel out something, right? Yeah, so up here there's missing a factor of just x, right? Just one x. So if I add x and subtract x at the same time, you get this. Subtract it there, add it there. Like so. See that? Okay. So now on the denominator I have this, and now I'm in a position to cancel. Yes? You can see what's going on. Now, that's okay, but this was an easy example. Like I said, that's kind of why I picked it out, right? So if we had something less obvious over here, how would you end up with this? How would you get that? This part here. Now what you're after really is the division transformation. Okay, you see why we did it in this order, like polynomials, all that kind of thing. How can I see that this, where am I going to get this x plus 1 from? This is really a remainder, isn't it? It's a remainder from the division transformation. So, how do we get it if it was a more complicated example? Okay, do a long division. I'll do it over here in another color. Okay, I'm dividing this by this. Divide this by this. Okay, so I've got x squared minus x plus 0 over here, and x squared minus x plus, sorry, wait, no, wrote the same one again. Plus 0x plus 1 here. Okay, so I'm just going to divide through. It's not going to take very long because they're the same degree, just so I can get the remainder out and know exactly what it is. Okay, because I'm trying to eliminate this guesswork bit. Some of you saw reasonably quickly that you add x, you subtract it, but others of you sort of stared at it for a little while because it takes some practice to see it, right? Okay, what's the first thing I do? Just long division. How many times does x squared go into x squared? Wow, cool. All right, I know it's early in the morning, but you did it. Good, right? So you multiply down, you get this. Right? Now what do I do with that? This is long division, so I subtract, don't I? So here I'm going to get x, right? It's 0 minus double negative, and you get 1 minus 0, so you get 1. Okay, aha, there's the remainder that I was after, right? Because I can't divide this into this anymore. It doesn't go any times. So there's my remainder. Okay, so what that's telling us is I can now rewrite it like this, which is actually the next step, right? How many times did it go in? It just went in the once, right? So that's this x squared minus x on x squared minus x. That's the one that hangs out the front, okay? And then what's left over is this. Okay, excellent. Now what? This is better than what we had before, okay? Because I've reduced the degree of this numerator. But what does that let me do now? Again, partial fractions, right? So you can see here it's easy to get out the factors, the linear factors. There's x and x minus 1. Do you need me to do it, or do you think you can handle it from there? Yeah, I think you can do that.